Hi there, my name's Joshua Smythe and I'd like to share with you another entry in my development series for my game Treasure Hunters. Now today I want to talk about a solution to a problem that I had that turned out to be very easy, although I thought it was very difficult. And you'll find this often in game development. If you just don't know how to solve a problem, it's almost impossible. And then once you find out what the solution is, it's basically trivial. It turned out that this happened in this case. The solution to the problem that I had is called triplanar mapping, and that's just a fancy way of saying we're going to use three textures and we're going to project them from the top and the two sides, and then we're going to work out what our UV coordinates are going to be in world space, and that's how we're going to make all of our geometry seamless. We're going to have no seams that are obvious, and it's going to blend together really nicely. So my problem was a little bit different to how it's usually used, because it's usually used in terrain where there are steep cliffs. So here's a very good article explaining triplanar mapping, and you can see the texture is very stretched here because it's only using one texture which is coming from above. And then here's a picture down here about, okay, they're using some textures from the sides, so all of a sudden this is not super stretched. And here's kind of an image saying like how the three different textures kind of come together. And then what we do is we blend how much of each texture based on the normal of the geometry there. So this works really well for terrain, and it also works really well for games that have concave geometry. So if you're using if your game has, say, procedural content where you're constructing dungeons sort of programmatically at runtime, and you want to sort of texture map them, like my game, although my game's not procedurally generated, we are creating dungeons from small pieces, so we need a way to work out how to texture map that so we don't have seams. Turns out triplanar mapping, that's the solution. So here, just to show you, is what, this is not the game, this is a separate project which I've just started, and I do this quite often. If I've got a problem that I want to solve, I like to sort of isolate it and solve it external to the code base, because there's no point working on something if I don't even know it's going to make it. So this was just like a prototype to see if it would work. So you can see our cave model, it's made up of sections, and there's a big ugly seam here, and every time that the model repeats you can see this big ugly seam. So once we implement triplanar mapping, if I hit a button, all of a sudden that seam has gone, because our UV coordinates are no longer based on the geometry, the individual geometry sections, but rather they're based in world space across all of the geometry, and it just tiles and repeats. So if I go to this kind of view here, this is showing you how much of each texture is made up into the final texture piece. So the green is kind of the ceiling, and then the red is the walls, and then the blue is the walls from the other plane, and that all comes together to kind of produce the texture mapping, and it works really well, and I like it a lot more than having big ugly seams. And this is really good for workflow as well, because now we don't need to even worry about UV mapping. We don't need UV maps in our models at all. So as long as we construct each piece of geometry such that with respect to rotation it kind of all snaps together, in the shader itself we can work out what the texture mapping is supposed to be. So I can go through very quickly how the shader works, and I'm only using one texture, but I'm sampling it 3 times. If you're using terrain, you might have a grass texture, and then you might have like a more rocky texture to use for the cliffs, but for my caves, one texture 3 times. So it's actually really simple. It's all calculated in the vertex shader in my example, and all we need to know is where is the vertex in world space, and based on that plus the normal, we can calculate how much of each texture contributes to the final pixel color. The first part, we just kind of work out what our world view projection is going to be. So in world space, we can work out what our Cartesian coordinates for the UV is going to be. Turns out we need to like offset that by the camera, because the camera can alter sort of where it is. If you don't do this, you get a nice like shimmery kind of textures as they kind of move and scroll, and it's all very weird looking. And then we just kind of sample based on a texture scale. So I mentioned the textures can like repeat across the different planes, and the texture scale just kind of controls how quickly, how big they look, basically, and this is a value you can change. Additionally, I offset the texture mapping based on whether it's on the left or the right side of the tunnel. So in object space, the tunnel 0, 0, 0 is kind of in the middle, and then you got like a negative on either side that produces the walls. And I just do a little offset so that it's not obviously symmetrical. And that was one minor change that I made in my implementation. And then you just kind of have to work out how it blends based on some kind of plateau. So that's another issue, is like if your geometry is all at 45-degree angles, you don't really want to contribute 1/3 of each texture, because it'll kind of look a bit blurry. So you kind of give it a little bit of bias based on the plateau. So maybe your grass kind of can grow quite steep, and then it kind of turns into rock, or maybe it's the other way around. Maybe the rock kind of falls out and it has kind of the bias, and then it transitions into grass. That's not such a big deal for my problem, but maybe if you're using this in terrain, it might be. And then the pixel shader is very simple. We sample 3 times based on where we were going to sample it from, based on the world space coordinates, and then just kind of blend all those together and to produce one color. So it's pretty efficient, and again, it's really the workflow that it helps to solve. So not having UVs, not having to UV map anything, will save us a lot of time when it comes to making the caves for the game.